Lesson 1, Planning an Experiment to Investigate the Speed of Water Ripples. This starts with a simple recall task. This equation, called the wave equation, you need to know off by heart, and you should know both in words, symbols, and you also have to know the units for each of the quantities. So the wave equation says that the wave speed is equal to the frequency of the wave multiplied by the wavelength. We can write that in symbols with the symbol V representing wave speed, frequency represented by the letter F, and wavelength represented by this Greek letter that looks like an upside down Y. The units for speed are meters per second. The units for frequency are hertz. That's either written as HERTZ, the name of a scientist, or capital H small z, and the units for wavelength are meters. Then we've got some practice questions to do. In all cases, you must show you're working. You have to write out all the quantities, both the name and the value, and you should check to see if you've got any conversions to do. Then from those quantities, you can say, this is the equation I need, and you write out the equation. At this stage, if you want, you can rearrange the equation if you need to. Then the third step is you substitute the numbers into the equation, and then finally you do the calculation. You must always remember to check that you've written the answer with the units. So we have question 1. Calculate the wave speed, and it tells us the units that it wants the answer in, meters per second, for the following waves. We've got a sound wave in steel with a frequency of 500 hertz and a wavelength of 3 meters. So step 1, I write out the quantities. So I've got the frequency is equal to 500 hertz. The wavelength is equal to 3 meters, and we're looking for the speed. Step 2, the only equation that has these 3 quantities is the wave equation. So we've got the wave speed is equal to the frequency times the wavelength. Step 3, the wave speed is equal to 500 multiplied by 3. So step 4, that gives me that the wave speed is 3 times 5, which is 1500 meters per second. Then we have question 2. A ripple on a pond with a frequency of 2 hertz and a wavelength of 0.4 meters. So again, step 1, we write out the numbers. We've got a frequency of 2 hertz. We've got a wavelength that is 0.4 meters. We're looking for the speed. Step 2, we've got speed is equal to frequency times wavelength. Step 3, we've got speed is equal to 2 hertz multiplied by 0.4 meters. And step 4, we have speed is equal to 0.8 meters per second. To become good at engineering or physics, it's important to always think about whether the numbers make sense or not. You'll see in this first one, the speed here I've got is 1,500 meters per second. That's a very large speed. We know that the speed of sound in air we can find this, it's one of those numbers that you need to know, and we can find it from our revision guide, which says that here we have the speed of sound in air is 330 meters per second. 330 meters per second. So our answer is very much larger than this, about 5 times larger, 4 or 5 times larger. So we might ask the question, is this realistic? So I'm going to tell you that yes, this seems like a reasonable answer. And you can think about this question, why does sound travel faster in a solid than in gas? Okay, and for the second answer we got an answer of 0.8 meters per second. And what I'd like you to do is you can compare this answer to walking speed. And again, this is one of those numbers that you need to know. It's given in your revision guide. Okay, let's move on to the next page. We've got more calculations to do. So we start at the top. We've got a radio wave. It's a wavelength of 30 meters and a frequency of 10, and then there's 6 more zeros afterwards. So again, I'm going to write out the numbers. Wavelength is equal to 30 meters. Frequency is equal to, and I'm going to write this in standard form. I've got 1, 2, 3, 4, 5, 6, 7 zeros. And I'm looking for the speed. Step 2, my equation. I always write out V is equal to frequency, speed is equal to frequency times wavelength. That gives me that the speed is equal to 1 by 10 to the power of 7 multiplied by 30, which gives me the speed is equal to 3 by 10 to the power of 8 meters per second. Okay, so what you can do here is compare this answer to the speed of light. And then you can say, is this a reasonable speed then for a radio wave? Okay, so continuing now, in the next question we're calculating wavelength, we're no longer calculating speed, and we're looking at the following waves. So number 1, we've got a wave on a slinky spring with a frequency of 2 Hertz traveling at 3 meters per second. So again, I write out my numbers. I've got frequency is equal to 2 Hertz. I have the speed this time is equal to 3 meters per second. And I'm looking for wavelengths. So step number 2, I write out the equation. And I could at this stage do any conversions that I want to do. So here I'm looking for wavelength. So I can rearrange the equation to give me wavelength is equal to speed divided by frequency. Then step 3, wavelength is equal to 3 meters per second divided by 2 Hertz, which gives me step number 4. And take out your calculator, you put the numbers in. 3 divided by 2 is 1.5. And notice that I write that as 1.5. I don't write it as a fraction because in physics we never use fractions. Okay, next one, we've got ultrasound wave. The frequency of this is 40 with 3 zeros Hertz, so that's 40,000 Hertz, traveling at 1,450 meters per second in fatty tissue. What is its wavelength? So again, number 1, I've got the frequency is equal to 4 by 10 to the 4 Hertz. And I've got the speed is equal to 1.45 by 10 to the 3 meters per second. And therefore I've got the wavelength is what I'm looking for. Number 2, I've got speed is equal to frequency times wavelength. I'm not going to rearrange here. I'm going to show you that we can do the rearrangement after we've done the substitution, if you prefer. So now we've got 1.45 by 10 to the 3 is equal to 4 by 10 to the 4 times the wavelength. So now I have to rearrange, dividing both sides by 4 by 10 to the power of 4. So that gives me that the wavelength is equal to 1.45 multiplied by 10 to the power of 3 divided by 4 multiplied by 10 to the power of 4. Now the power of the standard form is going to become very clear when we want to look at our answer. So First thing I'll do is, as usual, I pop that into my calculator and I do the calculation, and it gives me an answer of 3.6 by 10 to the minus 2. 3.6 by 10 to the minus 2. And that's in meters. Now, this is one of the advantages of using standard form. I would always say that you must always use your calculator when doing calculations. We're not interested in physics in your mental arithmetic, so you always use your calculator to work out your answer. However, when we've got standard form, it does allow us to quickly check roughly what sort of size of number would we get if we're doing this calculation. So here we have a number that's 10 to the power of 3 divided by 10 to the power of 4. So this tells us we end up with a number that is a tenth. And because I've got 1.5 divided by 4, my answer I'm expecting to be somewhere less than a tenth. Not as small as a hundredth, so somewhere between a hundredth and a tenth, which is what we end up with. So that gives me confidence that I've put the numbers into my calculator correctly. Right, and then we've got the final one, which is the frequency. If the sound wave is 440 hertz, it's traveling at 340 meters per second. And again, we're looking for the wavelength. So we'll use the same equation. This time I've rearranged it beforehand, which gives me the wavelength is equal to 340 divided by 440, which gives me the wavelength is equal to 340 divided by 440. That's equal to, now in your calculator, what you would get, and it's hard to see there, but you might get an answer that's written in your calculator looking something like this: 0.77 recurring and 2, something like that can be shown in your calculator. It also could be shown as a fraction, 17 over 22. This is not how we write the answer. We have to round in physics. We always round. So in this case, the answer is 0.772. So we round this, and because the question is given to two significant figures, we can give our answer to two significant figures. So in that case, that would be 0.77 meters. So do not use fractions, and do not write answer as a fraction or using the recurring dot. Do not do that. We always round to the appropriate number of significant figures. In this case 2, because I've got 2 in the question. If you're unsure, nearly always 2 decimal places is a good way to give your answer. And then finally, question 3. So in this case, we're trying to calculate the frequency. So again, with step 1, we have the wavelength is equal to 10 meters. We have the speed is equal to 340 meters per second. And we're looking for the frequency. So write out the equation. Speed is equal to frequency times wavelength, which gives me that frequency is equal to speed divided by wavelength. So that gives me that the frequency is equal to 340 divided by 10, which gives me the frequency is equal to 34 hertz. And for the second question, we've got the wave on the sea with a speed of 8 meters per second. So the speed is equal to 8 meters per second, and its wavelength is 20 meters. What's the frequency? So we have speed is equal to wavelength times frequency. And again, in this case, I'll just do the substitution first. So I get 8 is equal to 20 multiplied by the frequency, which gives me the frequency is equal to 8 divided by 20. So putting that into my calculator, I get an answer of the frequency is equal to 0.4 hertz. Right, and then finally we've got a microwave of wavelength 0.15 meters traveling through space at this large speed. So again, I'll use standard form. We've got the speed is equal to 1, 2, 3, 4, 5, 6, 7, 8. 3 by 10 to the power of 8 meters per second. And the wavelength is equal to 0.15 meters. And we're looking for the frequency. So number 2, we've got speed is equal to wavelength times frequency, which gives me the frequency, speed divided by the wavelength. So that gives me the frequency is equal to 3 by 10 to the power of 8 divided by 0.15 meters. So number 4, writing out the answer, I've got 3 to the power of 8 divided by 0.15. So that gives me an answer of 2 by 10 to the 9 hertz. 2 by 10 to the 9 hertz. In other words, there are 2 followed by 9 zeros waves every second of this microwave.